In this video, I'll be replacing the front and rear U-joints on the 2002 Mustang GT. The first step is to remove the drive shaft, which in a nutshell amounts to unbolting the 4 bolts at the pinion flange and pulling the drive shaft out from under the car. But there are some devils in the details. So if you want all the details on the removal and installation of the drive shaft, click on this link here for a video on just that. Once you have removed your drive shaft, the next thing you want to do is check your slip joint shaft for any signs of wear. The thing you're looking for is when you run your fingernail across, it should glide smoothly and not catch. Now you should expect to see some minor lateral scoring, but if you see even some minor longitudinal scoring, that would be something to be concerned with, because that's not something that would occur under normal wear. You may have damaged it in removal, or perhaps someone worked on it before you and wasn't careful. Once you determine that your slide yoke shaft is serviceable, you should wrap it in a clean rag to make sure that it stays that way. And electrical tape works well to secure it. The next thing you want to do is make witness marks on the mating yokes, because it is possible to install the yokes 180 degrees opposite of how they were originally installed, and that could potentially cause the drive shaft to be out of balance. If you drill a shallow hole with a 1/16 bit, you'll get a highly visible and permanent witness mark. And of course you should add witness marks to the yokes on the other end in the same fashion as well. The next step is to remove the retaining clips, which are basically inner circlips. The jaws of regular pliers are going to be a little too wide, so the best tool to remove these would be needle nose pliers, but I'm too lazy to go back to my toolbox to get them, so I'm going to use a pair of dikes since I have them right here. Now, dikes, which are properly called diagonal cutting pliers, aren't the ideal tool for this job, so I'll use a screwdriver to assist me. But the other thing to keep in mind is that it doesn't matter if you damage the circlips. They are expendable. As a matter of fact, you don't want to reuse them. The new U-joint comes with new circlips. The only thing you have to be concerned with is that you don't damage the groove. So even though they're not the best tool for the job, in this case it really doesn't make much of a difference. Okay, I brought the drive shaft into my garage and I'm ready to remove the U-joints with my vise. Now this vise only opens up to 5.5 inches, but that will be enough to do the operation. Now if you have an arbor press or a hydraulic shop press, that would be a better option. Now if you don't have any of these tools, or your vise has a jaw capacity of less than 5 inches, you could still do this job with a ball joint press, which you can usually rent or borrow from most auto parts stores. In fact, a ball joint press would be a better choice than a vise, because at the bearing surface of the anvil it has an open bore, so you wouldn't need to use a spacer. Of the 4 tools I just mentioned, the only one I have in my garage is a vise. But I don't feel like driving to my shop to use my press, or driving to an auto parts store to borrow a ball joint press, because the convenience of the vise right here, right now, far outweighs any advantage I would gain by using any of the other tools. And perhaps most importantly, the outcome of the job will be of the same quality regardless of which tool I use. Okay, now that I've explained why I'm using a vise, even though it's not the best choice, I'll get on with the job. So the first step would be to get a socket that's slightly smaller than the bore of the yoke, so it doesn't hang up in the bore when you're pressing out the bearing cap. Then spray all 4 bores with some type of penetrating oil. Next, secure the yoke in the vise with the socket against the bearing cap. Now at this point, you need to tighten the vise so you can press the bearing cap into the yoke, which in turn, through the spider, will press the opposite bearing cap out of the yoke. Now, since I don't have a spacer on the opposite jaw of the vise yet, I can only press the bearing caps until the opposite bearing cap comes in contact with the opposite jaw of the vise, making it flush with the outer edge of the yoke. The reason I haven't used a spacer yet is because, as you'll see, it's going to take a lot of breakaway force to get these bearing caps moving, and I feel it's just easier to get it started with less components. This is taking a lot of force, so I'm going to have to use a cheetah pipe. Now, a word of caution. You have to know your vise. This is a Wilton made in USA, so I know it can handle the added force that I'm going to impart with a cheetah pipe. However, if you got a Harbor Freight special, you might very well wind up breaking your vise. Okay, it broke free. It's moving. Now I feel a sudden increase in resistance, so I know the opposite bearing cap is probably in contact with the opposite jaw of the vise. Okay, let me check. Yeah, it's just about flush. Okay, now I need to open the vise as much as I can so I can fit a spacer that has an inner diameter slightly greater than the bearing cap, so I can press the bearing cap into the spacer and out of the yoke. Unfortunately, the vise doesn't open up wide enough to use a socket as a spacer, so I'm going to have to come up with something that's a bit thinner to use as a spacer, and I'll be right back once I find something that'll work. Okay, I already started to press the bearing caps out with the spacer, but I forgot to hit the record button, so I'll bring you up to speed. The spacer I came up with, which was shallow enough so it wouldn't exceed the 5-inch capacity of this vise, was a box wrench. And a 27mm wrench gives you the proper clearance. But if you don't have a 27mm wrench, you could use a 1 1/16 wrench, because for all practical purposes, they're the same size. Well, if you want to split hairs, and I mean literally split hairs, a 1 1/16 wrench is just barely 1/2 of a thousandth of an inch smaller than a 27mm wrench. And a human hair is 1/1000th of an inch. So there you go.
As you can see, I already pushed out a bit of the way. I'll continue the rest of the way. See here, this bearing cap is almost, you can see it's almost out of its bore in this direction, and that one just is barely starting to come out. So, as I said, this wrench fits over, so I'm going to use it as a spacer on the other side. Position this on. I'm using a ladder here to support the other end, makes your life a little easier. Garage is a mess. I've been using it. I'm like in the middle of various jobs, so it's been like a more of a storage area than a work area, so I just bulldoze my way over here. Get this back in. Okay, like I said, extra care lining up your spacer on this side when it's flush, because you got to make sure that the bearing cap is not going to hit the spacer or wrench, or whatever you're using as a spacer. So here I go. Now I can press the rest of the way, and here you can see we're out. So that came free. Drop my socket. Now there's not enough movement here to get that out without taking out the bearing cap. So the bearing cap does have to come out the rest of the way. Oh, look at that. That's a good sign. It came out pretty easy. So just by hand, okay? Bearing cap out of the way. Should be able to now take the whole unit out. This is my slip yoke in my hand. This is the mating yoke on the drive shaft for the slip yoke. Now, next thing is to do the slip joint. So
It'll be the same process to remove the remaining part of the spider from the slip yoke. I'll add a little bit more penetrating oil here and here. Now I'll put it in the vise with the socket against the bearing cap and tighten it up. Again, I'll use a cheetah bar to overcome that initial breakaway force. Whenever you're using a cheetah bar on a vise, just use common sense. If you're applying a lot of force and nothing's moving, just stop and check to make sure that your socket isn't hanging up on the side of the yoke. Okay, it's moving. And again, the most you can press it out at this stage is until the opposite bearing cap comes in contact with the opposite jaw of the vise. But that's okay, because the point of this step is to overcome the breakaway force and to get your pushing spacer partially into the bore of the yoke so you don't have to worry about centering it on your next step. Alright, I think I pressed it about as much as I can. Let me check.
Just about flush with this bearing cap. So now I'm going to put the wrench as a spacer on the other side.
Make sure your assembly is centered in the jaws of the vise and centered on the bearing caps. Then tighten the jaws of the vise just enough to hold everything in place. And then center your spacers. Now I don't need to worry that the spacer that's doing the pushing, in this case the socket, is centered, because that's already in the bore from the previous step. I only need to check that the spacer that the bearing cap is going to be pushed into is centered, and in this case it's a wrench. And it doesn't appear to be quite centered, so I'll take a hammer and give it a few light taps to get it into place. And I can verify that it's centered by feeling around to check that it's concentrically even around the boss of the yoke. Now I can continue to press the bearing caps and the spider out the rest of the way and into the spacer. As you can see, I'm not using a cheetah pipe because once you've overcome that initial breakaway force, it should move fairly easily. And if it doesn't, just stop and check to make sure it's not hanging up or that you have some other kind of issue.
Okay, so that went through and fell in a bucket down here. As you can see, luckily, that was just luck. But more importantly, I did have this protected because, hey, no matter, I was a little careless there. Fortunately, no harm done. Let's see if I'm lucky on here too. Yes, this comes out. Got lucky. I mean, if it wouldn't come out with your fingers, pair of pliers or vice grips, you could grab it and pull it and twist it out the rest of the way. So there you go. Spider's out. Now I'll clean this up a little bit.
I'll just grab this old piece of Scotch-Brite laying over here. It really doesn't matter. You could use steel wool, 180 grit sandpaper, whatever. It's not that critical. You just want to remove the rust ridges from the bores and clean them up a bit. It really shouldn't take more than a few minutes. And while you're at it, clean up any loose rust or grit from the yoke in general, because you don't want any of that falling into your new bearing caps or spider journals when you're reassembling your U-joint. The other thing you want to do is clean out the grooves for the Circlips. I took an old Circlip and bent it like this, so now I can use it to scrape out the grooves to make sure they're clear of any rust or debris. And the grooves shouldn't really be that bad because the original Circlips were just removed. And as a finishing touch, take some brake cleaner and spray it down to remove any residual rust, grit, and grease. And there you go, it's clean enough. Of course, you could always clean it more, but this is as far as you have to go to ensure a proper job. Any more is just aesthetics. And now I'll give the same cleanup treatment to the mating yoke on the drive shaft. And I'm not going to bother to film that because it's the same deal and not all that exciting. The mating yoke on the drive shaft is all cleaned up now, so I'll get that out of the way because it'll make life easier to press the U-joint into the slip joint first. Here's the new U-joint. The 2002 Mustang GT uses a very common U-joint, a lot of cars use it, and the part number in Moog is 354. It'll cost you about $20 to get it in Moog, which actually exceeds factory spec, so it's cheap enough, you might as well splurge. The new U-joint will come with new Circlips, and in this case, since it's greasable, a Zerk fitting. The stock U-joint is lubed for life and has no grease fitting, and can't be lubed after it's installed. Here's a quick comparison between the stock U-joint and the Moog U-joint. As you can see, the body of the spider of the Moog U-joint is a bit more substantial. The outer diameters of the bearing caps have to be the same size because they have to fit into the bores of the stock yoke. However, the diameters of the spider journals appear to be slightly greater, maybe by a few thousandths. So I would suppose the needle bearings on the Moog would have to be of a slightly smaller diameter to allow for that. And the journals on the Moog seem to be slightly shorter. I don't see much of an advantage to that, but it is what it is. I don't really see the Moog to be much of an upgrade over stock. Basically, it's just a high-quality replacement part, with the only significant difference being that it's greasable. And even that's not so significant when you consider that the stock U-joint lasted over 150,000 miles without intermediate greasing. Okay, so I'm ready to press the new U-joint into the slide yoke. First, I'll lube the bores. The only reason why I'm using chain lube is because it was sitting right here on the bench. The type of oil you use isn't all that critical, although a low viscosity oil such as 10 weight or machine oil would be your best choice because it's an interference fit, whereas grease would be your worst choice. Which doesn't say much for my choice because chain lube is kind of high on the viscosity scale, but it's better than nothing. And I'll put a little lube on the bearing caps too. In order to install the U-joint, you have to remove the bearing caps. Now use caution here. As you can see, it has needle bearings, and they're not in a cage. The only thing holding them in place is the grease. And if even one of those needle bearings fall out of place, it'll ruin the entire job. So it is crucial that you ensure that they don't. So after you've confirmed that all your needle rollers are present, which is easy enough to tell because there should be no gaps between rollers, it's a good idea to pack the bearings well with additional grease. You could use general purpose grease for this, but you should use wheel bearing grease because it's rated higher. The brand I'm using is Lucas Red and Tacky, but the brand doesn't matter. What matters is its rating. As you can see, it's NGLI rated, and it's GCLB. GC means general chassis, and LB means wheel bearings, so that makes this the right stuff. Now I'm ready to press it in. The bore is slightly tapered, so it should just take a finger press to get it started. Then you'll need your vise to press it in the rest of the way. I'm only going to press it in a little at first, just enough so that the boot is barely protruding, because I don't want it to interfere with getting the spider into the yoke. As you can see, the boot is barely protruding to the inside of the yoke, and the bearing cap is nowhere near flush with the outside of the yoke. Now I'm ready to put the spider in place. But before I do that, it's important to note where the hole for the Zerk fitting is. You want to make sure the hole is facing away from the slip yoke, otherwise it'll be hard to get a grease gun in there because the transmission will be in the way. While holding the U-joint in its proper orientation, remove the opposite bearing cap. Then dive the opposite journal into the opposite and empty bore of the yoke. Then carefully guide the journal into the partially pressed in bearing cap without disturbing the needle bearings, and slide it in as far as it'll go. Now take your other cap that you've already packed well with grease and insert that into its bore. Then clamp the entire assembly in the vise, being very careful not to jar or shock it. Because even though you pack that extra grease in there, it's still possible that any impact could dislodge those needle roller bearings. Now, while supporting the spider so the journal is centered on the bearing cap, gradually tighten down on the vise until both bearing caps are flush with the outer edges of the yoke. Now that both bearing caps are flush, you can take your bearing driver, in this case a socket, and press the bearing cap in until it is just below the groove for the circlip. Okay, this bearing cap is just about there, so I'll flip it around and do the same to the other side. Again, ideally, you just want to press it in until it's just below the groove for the circlip. You don't really have to worry about pushing it in too far, because there's only enough room for the bearing caps to fit in between the circlip grooves. So if you pushed it in too far, you would see the opposite bearing cap start to move. If that happened, all you'd have to do is flip it around and press back on the bearing cap until both bearing caps are centered between the grooves. But if you're using a factory U-joint, you might want to be more careful because it has nylon thrust discs at the end of the bearing caps. And pressing the spider journal against the thrust disc might distort it. In the case of this Moog U-joint, that's not a concern because the ends of the bearing cap are solid steel. It does pay to examine how your particular U-joint is constructed so you know where it's safe to apply forces. Now that the bearing caps are centered between the circlips, I can go ahead and install the circlips. Just take a pair of needle nose, squeeze the circlip together, and insert it in its groove. Now it seems I didn't press this bearing cap in far enough because the circlip is not fully seated in its groove. An easy way to remedy that is to take the bearing driver, place it against the circlip, and press it in until it snaps in its groove. There you go. You can see the circlip is now fully seated in its groove. Now I can go ahead and put the other circlip in. Again, I'll take a pair of needle nose, squeeze the circlip together, and insert it in its groove. And yet again, as Yogi Berra would say, it's like deja vu all over again. It's not fully seated. So I'll just do the same as I did on the other side and place the bearing driver over the circlip and press in until it snaps in its groove. Truth is, this actually isn't a bad way of doing it because you know you've never pushed the bearing caps in deeper than they needed to be. And it would be the perfect technique to employ when installing a factory U-joint where you don't want to impart any excessive force onto the inside of the bearing cap. You just have to press down a little and you can feel it snap right in. And there you go, it's fully seated. Now that the slide yoke portion of the U-joint is completed, I just have to basically do the same thing for the drive shaft yoke. Now, as far as orientation is concerned at the drive shaft yoke, the only thing I need to be concerned with is the witness marks that I made before I dismantled the drive shaft. And this orientation is important because it guarantees that you maintain the factory balance of the drive shaft. Aside from orientation, I'll use the same process I used on the slip yoke to finish the installation of this front U-joint onto the drive shaft. So I'll just zip right through it. Remove your bearing cap, check the needle roller bearings, and pack it with grease. I didn't pack it with grease this time because I like to live life dangerously. Lubricate the outside of the bearing cap and the inside of the bore with a light viscosity oil. Then press the bearing cap slightly into the bore with the vise. Next, remove your remaining bearing cap. Next, take your U-joint assembly and angle one of the journals into the empty bore. Then carefully guide the other journal into the bearing cap without disturbing the needle bearings. Next, take your remaining bearing cap, which you have already packed with grease and lubed externally with oil, and press it into the bore by hand. Then carefully clamp the entire assembly into the vise without jarring or shocking it, and tighten the vise until both bearing caps are flush with the outer edges of the yoke. Next, take your bearing driver and place it against the bearing cap, and press it in until the bearing cap is just behind the circlip groove. Next, rotate the assembly 180 degrees and do the same thing to the other side. Then install your circlips with a pair of needle nose pliers and make sure they're seated properly in their grooves. Okay, the front U-joint is just about complete. There's only two things left: to install the Zerk fitting and grease it up with a grease gun, which I'll do right now. Zerk fitting goes in with a 5/16 socket. Careful not to tighten it too tight. It's only a 1/4 28 thread and hollow at that. And now that the Zerk fitting is in, I can grease it up.
That's done. Now I do the other side.
Spin it around and replace the rear U-joint. Now at this point it's getting pretty monotonous. As a matter of fact, even the drive shaft yoke was fairly redundant after completing the slip yoke. That's why I got this on fast forward. Even the part numbers for the front and rear U-joints are the same. They're interchangeable. So there really isn't anything new to see here. It's pretty much the same thing, just a different end. It's actually even getting more monotonous, if that's even possible. So I'm just going to skip to the end of this installation of this rear U-joint. Okay, the installation of the rear U-joint is just about complete. I just finished installing the Circlips, so all that's left is to install the circ fitting and grease it up. And when you grease it up, make sure you see grease come out of all 4 boots. That way you know it's fully lubed. Okay, the front and rear U-joints are done. Now the last thing to deal with before I put the drive shaft back in the car is the slip yoke shaft. It's just a minor detail really, because I've already determined that the shaft of the slip yoke is serviceable. However, it does have some minor scoring, scuffing, and glazing from normal wear. So I'll sand it down with some 400 grit wet or dry sandpaper. This is an old piece clogged with polyurethane from a woodworking project. But that won't do the steel any harm, especially after I lube it with some penetrating oil. 400 grit is coarse enough that it will do a fairly good job in breaking the glaze, removing the scuffing, and getting rid of some of that minor scoring. But fine enough that it won't affect the tolerances in any way. That is, as long as you don't get too carried away in the sanding process. The idea is to sand it down until you have removed the glaze. And that'll be achieved when you see a uniform matte finish. Some minor scoring might still be apparent, but if you try to go after that, you run the risk of taking it out of tolerance. The whole sanding process shouldn't really take more than a few minutes. There you go, it's done. I'll just give it a quick spritz with some brake cleaner. And now the drive shaft, along with its new front and rear U-joints, is ready to go back in the car. Replacing the drive shaft is basically the opposite of removal. The key points are to clean the tapped holes in the pinion flange thoroughly with solvent, and if you're using the old bolts over again, clean their threads in the same way. The reason for this is because you need to use Loctite, and for Loctite to work properly, you need clean threads. If you're using new bolts, they'll come with Loctite already on them, but you'll still have to make sure the holes in the flange are clean. Then torque the bolts down to 83 foot-pounds, and you're good to go.